Okay, here we have section 2.7, proving segment relationships. So our main ideas, and no new vocab in this section. So a couple postulates to begin. The first is just the ruler postulate, means you can just measure a segment with a ruler. The second is the segment addition postulate, which says that if you know that 3 points are collinear and know which one's in the middle, then endpoint to middle plus middle to other endpoint is the full length, or vice versa. If you know that that is true, it tells you which point is in the middle. So example 1 here, prove the following. Given PQ is equal to RS, prove that PR is equal to QS. So when you do a proof, you always start with your given. So if you notice, so PR includes PQ and QR, and QS includes QR and RS. I already have a PQ and an RS here, so I can add QR to both sides. So this is just the addition property. So you can, as long as you add the same thing to both sides, you're fine. Now PQ plus QR is PR, QR plus RS is QS, which is actually my proof statement, and this is by segment addition. So be careful, because addition and segment addition aren't the same thing. Segment addition is when you take 2 segments and combine them down into 1. Addition is just when you add the same thing to both sides. And that's, you're done because you're at your proof statement. So a couple more theorems here. Theorem 2.1, which is the midpoint theorem, just says if you know which point is in the middle of a segment, you know the 2 parts are congruent. And then the reflexive, symmetric, and transitive properties for segments being congruent as well. So AB is congruent to AB. Normally these properties only refer to equations, so AB is equal to AB, but you can also have congruence as well. So down here, example 2, once again another proof. So you're given all of that fun stuff, and you're asked to prove that GH and JK are congruent. So JK congruent KL, HJ congruent GH, KL congruent HJ. All of that is given. So I need to get GH and JK. So I know that JK is congruent to HJ by the transitive property, because they are both congruent to KL. I also then know that JK is congruent to GH because of, once again, transitive property. HJ and JH are congruent. Now, careful, because these look similar, but they're not the same. I need to turn this guy around, GH congruent JK. And if you reverse an equation, that's a symmetric property. So there we go at the bottom. And that's it for the section.